We live in the age of satellites. In 2026, there are over 8,000 active satellites orbiting Earth, more than at any time in history. They connect our phones, guide our cars, predict our weather, and watch over our planet. But 2026 isn't just about quantity, it's about quality. This year, we've launched the most powerful satellites ever built. Satellites with antennas the size of tennis courts. Satellites that communicate with lasers at speeds that would have seemed like science fiction a decade ago. Satellites that think for themselves using artificial intelligence. This is the story of the strongest and latest satellites of 2026. It all started in 1957 with Sputnik, a simple radio transmitter the size of a beach ball. Today, we have satellites the size of buses, constellations of thousands, and technology that our ancestors couldn't have imagined. The satellite revolution is driven by three things: cheaper launches, miniaturized electronics, and insatiable demand for data. In 2026, we're seeing the fruits of that revolution: record-breaking performance, unprecedented capabilities, and satellites that are redefining what's possible in space.
In this documentary, we'll explore the most powerful satellites launched in 2026, from Amazon's massive internet constellation to China's latest weather watcher, from India's AI-powered Earth Observer to America's next-generation GPS, from laser communication breakthroughs to the largest commercial antenna ever deployed. This is the complete story of 2026's most impressive machines in orbit.
On February 12, 2026, a new chapter in space-based internet began. From Europe's spaceport in French Guiana, an Ariane 64 rocket, the most powerful version of Europe's new heavy-lift launcher, roared to life. Its payload? 32 satellites for Amazon's Project Kuiper, now rebranded as Amazon Leo. This was the first of 18 planned launches to deploy a constellation of over 3,200 satellites. Today's successful flight marks a major milestone for Arianespace, for our customer Amazon Leo, and for the whole European space sector. The numbers tell the story. This was the first flight of Ariane 64 in its 4-booster configuration, capable of lifting more than 20 metric tons into low Earth orbit. That's about twice the capacity of the 2-booster Ariane 62 variant. The 32 Amazon Leo satellites were packed under a 20-meter-long ferry, the longest ever used on Ariane 6, giving the rocket a total height of 62 meters. 1 hour and 54 minutes after launch, all 32 satellites were successfully deployed into their target orbit at approximately 465 kilometers altitude. Like Starlink, Amazon Leo aims to provide fast, reliable broadband internet to customers and communities around the world, especially those that currently lack access to traditional internet or have poor coverage. The constellation will consist of approximately 3,200 satellites distributed across multiple orbital planes, deployed in clusters over 18 launches. Each launch positions several satellites on the orbital planes intended for the constellation, designed to provide fast, reliable broadband access to Amazon customers and communities around the world, even in areas that do not currently have access to traditional internet. This launch, designated LEO-1, Leo Europe 01, by Amazon, was particularly significant for Europe. It was the first launch for the Amazon Leo constellation performed with a European launcher. For Arianespace and the European space sector, it demonstrated that Ariane 6 could meet the demanding requirements of large-scale constellation deployments. This new success is a major milestone for the development of Ariane 6, as it was the first flight in the 4-booster version. This successful entry into service once again highlights the quality of the teams at Ariane Group and its European partners. With the success of VA267, Amazon Leo now moves into full-scale deployment. 17 more launches are planned, each carrying dozens of satellites. When complete, the constellation will join Starlink and others in providing global internet coverage from space. The race for space-based internet is on, and 2026 is a pivotal year. Just days before the Amazon Leo launch, another milestone was achieved in low Earth orbit. On February 10, 2026, AST SpaceMobile announced the successful unfolding of its Bluebird 6 satellite. This is no ordinary communications satellite. It features the largest commercial communications array antenna ever deployed in low Earth orbit, spanning approximately 2,400 square feet. Bluebird 6 is the result of specialized American manufacturing combined with world-class engineering ingenuity. 2,400 square feet. To put that in perspective, it's about the size of a tennis court. This massive phased array antenna enables Bluebird 6 to do something no other commercial satellite can: connect directly with standard, unmodified smartphones on the ground. No special equipment, no bulky antennas, just regular phones connecting to space. The aperture enables full 4G and 5G cellular broadband services, including voice, data, and video, to standard unmodified smartphones everywhere. The massive antenna isn't just for show. It enables peak data speeds of up to 120 Mbps, fast enough for streaming video, video calls, and all the applications we take for granted on terrestrial networks. It delivers up to 10 times the bandwidth capacity of the earlier Bluebird 1-5 series, and its size enables highly precise beamforming, creating narrower, more focused coverage areas that minimize interference and maximize network capacity. Bluebird 6 represents not just a technological achievement, but a manufacturing one as well. AST SpaceMobile operates nearly 500,000 square feet of manufacturing and operations facilities, and employs a workforce of nearly 1,800 people. The company is 95% vertically integrated, maintaining strict United States control over the entire manufacturing process. This level of integration allows them to iterate quickly and maintain quality control. We are not just building satellites, we built a new way to manufacture innovative space technology at scale. Bluebird 6 is just the beginning. AST SpaceMobile is on track to launch 45 to 60 satellites by the end of 2026, with launches planned every 1 to 2 months on average. The company has agreements with over 50 mobile network operators globally, representing nearly 3 billion subscribers combined. The vision is clear: global cellular broadband from space, accessible by every smartphone on Earth. Before 2026 began, China launched what may be the most powerful weather satellite ever built. On December 27, 2025, a Long March 3B rocket carried the Fengyun 4C satellite into orbit from the Xichang Satellite Launch Center. It's the third satellite in the Fengyun 4 series, and it represents a generational leap in meteorological observation capability. The main technical specifications have been improved by 2 to 3 times compared to its predecessors. Fengyun 4C carries an unprecedented suite of instruments: 4 different types of Earth observation remote sensing instruments and 2 solar observation instruments. It integrates comprehensive detection capabilities, including multi-channel 2-dimensional imaging, 3-dimensional atmospheric sounding, and lightning mapping. This is not just a weather satellite, it's a complete Earth and space weather observatory. The Advanced Geostationary Radiation Imager is a marvel of engineering. It has reduced its time for full-disk imaging from 15 minutes to just 5 minutes. That means it can scan the entire Earth-facing hemisphere 5 times faster than its predecessor. But the real magic is its sensitivity. It can detect atmospheric temperature changes as fine as 0.02 degrees Celsius from tens of thousands of kilometers away. The Lightning Mapping Imager is capable of capturing 500 frames per second. It identifies lightning events from a data stream of 30 gigabits per second, equivalent to playing back 30 high-definition movies in 1 second. From this torrent of data, it pinpoints every lightning flash, earning its nickname, Keen-Sighted Eyes. This real-time lightning data helps forecasters identify rapidly intensifying thunderstorms and issue earlier warnings. In February 2026, Indian space tech startup Galaxy announced Mission Drishti, a groundbreaking satellite slated for launch later this year. What makes Drishti special isn't just what it sees, but how it thinks. It features the world's first sync-fused optosar architecture, combining 2 different imaging methods on a single satellite. Mission Drishti moves the company closer to providing real-time intelligence from orbit. The sync-fused optosar architecture is revolutionary. One system captures detailed visual images, similar to photographs taken from orbit. The other uses synthetic aperture radar, SAR, to see through clouds, darkness, and even heavy rain. By merging these 2 methods, Drishti can produce consistent, dependable images regardless of weather conditions or time of day. This means no more waiting for clouds to clear. The satellite sees through them. Perhaps the most revolutionary aspect of Drishti is its brain. The satellite is powered by NVIDIA Jetson Orin computing hardware, enabling it to process much of its data directly in space using artificial intelligence. Instead of sending large amounts of raw information back to Earth for processing, a slow and bandwidth-intensive process, Drishti analyzes images in orbit and quickly delivers useful insights. GalaxEye envisions even more. Mission Drishti will test the concept of orbital data centers, where multiple satellites work together like a network of computers in space. Such systems could make future satellite networks faster, more reliable, and less expensive to operate. Imagine a constellation of intelligent satellites, each processing its own data and sharing insights with others. If successful, Mission Drishti could transform multiple sectors. In agriculture, it could provide faster crop health monitoring. In disaster response, it could map floods and fires in real time, even through clouds. For environmental tracking, it could monitor deforestation and ice melt with unprecedented reliability. And for national security, it could provide persistent, all-weather surveillance. It's invisible, but it's everywhere. Every time you open maps on your phone, every time an airplane lands in low visibility, every time a farmer precisely plants a field, you're using GPS. The Global Positioning System is one of the most critical infrastructures ever built, and in 2026, it's getting an upgrade. On January 27, 2026, SpaceX launched a Falcon 9 carrying the GPS-3 SV09 satellite from Cape Canaveral Space Force Station. This marked the 9th of the next-generation GPS Block 3 satellites launched since 2018. Designed by Lockheed Martin, this satellite is part of an ongoing effort to modernize the entire GPS constellation. What does Block 3 bring to the table? 3 times better positioning accuracy and 8 times stronger anti-jamming capabilities. These improvements benefit everyone, from the military user in a contested environment to the civilian driver navigating city streets. Looking ahead, the Block 3F satellites will introduce the constellation's first fully digital navigation payload. GPS is just one of several global systems. There's Europe's Galileo, Russia's GLONASS, and China's Beidou. Together, they provide redundancy and improved accuracy for users worldwide. When your phone calculates your position, it's likely using signals from multiple constellations. The competition in space-based navigation is healthy, and it benefits everyone. As satellites multiply, traditional radio frequency communication is hitting its limits. Spectrum is congested and bandwidth is finite. The solution? Laser communication. Optical data links enable satellites to rapidly and securely transmit complete data sets in a single burst, a significant improvement over legacy systems. In February 2026, the European Space Agency and Airbus announced a breakthrough. They successfully demonstrated laser communications between an aircraft and a satellite over 36,000 kilometers away. The Ultra Air system achieved a bit error-free data rate of 2.6 gigabits per second, maintaining a secure link despite platform movements and vibrations. This breakthrough has both civilian and defense applications. For defense, laser communications provide a secure alternative to radio frequency, with low probability of interception. For civilians, it could enable high-speed data connections for passenger airliners and ships, keeping everyone connected anywhere on the planet. China is quietly building its own massive low-Earth orbit internet constellation. On January 19, 2026, a Long March 12 carrier rocket lifted off carrying the 19th group of SatNet satellites. Developed by Galaxy Space, these satellites use advanced phased array and millimeter wave antennas that are both technologically advanced and cost-effective. Every satellite we launch is another nerve ending in a global nervous system. They watch, they connect, they guide, they protect. In 2026, that nervous system is growing faster than ever. We are moving toward a world where everyone is connected, every storm is predicted, and every part of our planet is understood. The strongest and latest satellites of 2026 aren't just machines. They're the foundation of our collective future. Thank you for watching this journey through the satellite revolution. Comment below. Which of these satellites impresses you most? Subscribe for more space documentaries.